Welcome to the Engineering Lab. Today, we are cracking open the ultimate senior examiner's playbook. Look, if you are aiming for top marks in Cambridge computer science and IT exams, and I'm talking specifically about syllabus codes 0417, 0478, 2210, 9618, or our main focus today, IT 9626, you are in exactly the right place. We're going to completely overhaul your exam technique. We are going to build bulletproof arguments with stress-tested evidence and rigorous quality control. But first, let's just get real for a second and look at the reality of the actual exam room. You've got the clock ticking, the pressure is on. Imagine two students sitting for paper 2 right now. First, we have Alex. Now, Alex is the kind of student who overloads every single answer with just raw, unfiltered computer science facts. He knows the textbook inside out, but he provides absolutely zero critical analysis. Then we have Sam. Sam's problem? Sam rushes through the paper, completely missing the specific requirements hidden inside the command words. So what happens? When the results come out, their papers are just absolutely covered in red pen marks. And you might be wondering why. Because knowing the technical facts about sensors and actuators, well, that's literally only half the battle. In this explainer, we are going to fix those specific mistakes live. We are going to transform those dreaded red marks into green check marks. This is exactly why our focus today lands squarely on topic 3.2, the advantages and disadvantages of different control technologies. Now, you might be thinking to yourself, well, this is just a minor subtopic, right? No big deal. But did you know that this specific area accounts for approximately 15% of the total marks in Paper 2 of Information Technology 9626? Yes, 15%. That is an absolutely massive chunk of your final grade. That is literally the difference between an average grade and a top-tier one. Let's think back to Alex's flawed answer for a second. Alex wrote this huge, sprawling paragraph listing every single component of an automated greenhouse. He was desperately hoping to score points through sheer volume alone. But guess what? The examiner awarded almost nothing. Sam, on the other hand, just wrote something super vague like, it is faster and cheaper, without explaining why or how. Listen to me. 15% of your grade is hanging by a thread on your ability to evaluate these systems properly. You absolutely cannot afford to lose these marks simply due to poor exam technique. So, to make sure we secure those massive marks, here is our roadmap for today. First, we'll cover the core principles. Second, we dive into the standardized methodology. Third, we're exposing the top examiner warnings. And finally, we will conquer critical analysis. Let's jump straight into Section 1, Core Theoretical Principles. The core theoretical principles are really where we begin to decode the assessment objectives that are completely specific to Cambridge computer science and IT. You see, the examiners aren't just looking for random facts. They are testing distinct cognitive domains. They're evaluating your knowledge and understanding, your practical application, and, most importantly, your analytical skills. Listen, examiners prioritize analytical depth over superficial breadth every single time. They desperately want to see logical, structured reasoning over the rote memorization of simple facts. And this is exactly where we introduce the PEEL framework. That's PEEL, point, evidence, explanation, link. Top students structure every single one of their answers using this exact framework. First, you make your point about a control technology, say, discussing the reliability of a PID controller in an autonomous vehicle. Then, you provide evidence directly from the scenario they gave you. After that, you offer a clear explanation of how that specific technology processes data to make a decision. And finally, you link it all the way back to the specific advantage or disadvantage that was actually asked for in the question prompt. Alex failed because there was absolutely no PEEL structure. It was just a massive dump of data. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. So, what separates the truly top-performing candidates from the rest of the pack? Let's do a quick mental exercise together to test this out. I'm putting 30 seconds on the imaginary clock right now in your head, okay? If I give you a paragraph that simply says, automated traffic lights are good because they reduce human error and work 24/7, can you spot the PEEL framework in that sentence? I'll give you a second. Time's up. The answer is a resounding no. There is a very basic point there, sure, but there is absolutely zero evidence, zero explanation, and zero link to the underlying control technology. A top-performing candidate wouldn't just stop there. They would specify the exact type of sensor used, they would explain the continuous feedback loop, and they would analyze the specific advantage of real-time processing over human intervention. Now that is analytical depth. Ultimately, the absolutely crucial point here is that top-tier answers always rely on these 3 main pillars: precise definitions, mapping out causal relationships, and making cross-topic connections. First things first, you have to precisely define the control system components. Don't be vague. Second, you need to clearly map out how an input directly causes a specific output. Show the chain of events. And third, draw those cross-topic connections. Integrating other areas of your syllabus, like networking protocols or data security, directly into your control technology answer yields significantly higher marks. It shows the examiner you understand the big picture.
Moving right along to Section 2, the standardized methodology.
We are officially moving away from chaotic, panicked exam writing into a highly structured, professional approach that practically forces the examiner to hand over those marks. The insider secret here, and you really want to pay attention to this, is that marks are awarded for process. We call this the method marks strategy. The Cambridge mark schemes don't just look to see if you got the correct final answer. No, they heavily reward strict procedural conventions. What does this mean for you? It means using proper headings to structure your essay. It means utilizing correct technical terminology instead of everyday layman's terms. It means ensuring your formatting is appropriate and providing crystal clear annotation of your logic. If you can show the examiner exactly how you arrived at your conclusion regarding the advantages or disadvantages of a control system, you are going to pick up method marks even if your final point isn't 100% perfectly polished. Let's walk chronologically through the exact 5-step standardized processing sequence you need to effectively tackle these past paper problems. I want you to visualize a 60-second timer on your screen right now as we mentally attempt to rewrite an answer. Step 1. Identify the key elements from the text and tables in the question prompt. What are they actually giving you? Step 2. Apply the relevant theoretical principles to those specific elements. Step 3. Execute your analysis using that Peel framework we just talked about, making sure you show clear working. Step 4. Verify your results against the command word. Did they ask you to evaluate, describe, or compare? Check your answer against that word. Step 5. Present your final answer in the appropriate format. Honestly, if you follow this exact 5-step computer science success blueprint, those red pen marks we talked about earlier instantly transform into green check marks.
Stop scrolling. Subscribe to our YouTube channel, Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Take a moment right now to mentally hit play on these new habits. Stop just scrolling through endless facts and start actually securing your grade by setting a mental notification for yourself today. Commit to reviewing this specific 5-step sequence before you sit for your next mock exam. Building this procedural muscle memory is exactly what transforms a totally average paper into one that shoots up 2 to 3 entire grade boundaries.
Let's get into Section 3, Top 3 Examiner Warnings.
All right, we are officially entering the minefield. These are the most common mark-destroying pitfalls that are cited over and over again in the Principal Examiner Report specifically for Topic 3.2. Here are the top 3 mistakes students make. Number 1, confusing cause and effect. Number 2, forgetting format and presentation. Number 3, providing generic, contextless answers. Let's put you to the test with Challenge 1, the data scan. Imagine a really complex computer science data table on your exam paper. It's showing performance metrics of a robotic manufacturing arm over a 24-hour period. I am giving you a 60-second visual countdown timer in your mind right now. Go. You need to extract the core trend from this data. Are the error rates increasing as the ambient temperature rises? What exactly is the relationship there? Look, interpreting relationships and drawing evidence-based conclusions from data tables is an absolutely critical skill. If you just list the data points without actually finding the underlying trend, you completely fail the analysis requirement. Let's move straight to our next interactive test. Challenge 2, find the flaw. I want to briefly unpack this critical definition of cause versus effect. In any control system, an input, like a sudden temperature drop, is the cause. The output, like a microprocessor turning on a heater, is the effect. Candidates frequently, and quite fatally for their grades, confuse these two when analyzing disadvantages. They will actually blame the actuator for a problem that was completely caused by a faulty sensor reading. You see, if the examiner sees you mixing up that fundamental input-process-output logic, your mark drops immediately. No questions asked. You absolutely must maintain strict causal relationships in all of your arguments. Now, let's look at a classic, screaming examiner alert, the generic answer versus the context-specific answer. Imagine reading a flawed exam response that just says, a disadvantage of control technologies is that systems can crash, requiring expensive maintenance. Sounds okay on the surface, right? Wrong. The examiner commentary on answers like this is absolutely brutal. If the exam scenario is specifically about an automated life support system in a hospital, giving a generic answer about systems crashing is completely inadequate. You must link every single point you make directly to the given scenario. A proper context-linked response would say something like, in the context of the hospital's life support, a critical disadvantage is that a software failure in the central control unit could lead to immediate, life-threatening delays in oxygen delivery, directly necessitating redundant physical backup systems. Do you see the difference? Context is absolutely king.
Here is a super quick, highly actionable memory trick to help you retain all this complex terminology when you're analyzing data tables and texts under massive exam pressure. Simply create a mnemonic using the first letters of the key terms you need to evaluate. Let's put this into practice right now with Challenge 3, Speed Writing. I am putting a 30-second timer on the clock. Your task is to write one perfect Peel paragraph evaluating a disadvantage of a central heating control system. Go! Remember your steps. Make your point. Pull evidence directly from the theoretical scenario. Explain the system logic clearly and link it all back. Practicing these speed writing drills with little memory hacks will drastically improve your efficiency. It ensures you will never miss a structural beat during the real exam.
Now for Section 4, Mastering Critical Analysis. Welcome to the final boss level of the exam playbook. Just getting the basic facts right is merely the baseline, but executing top-tier comparative and critical analysis is what actually secures the A-star. Take a really close look at the strict syllabus requirements on this table. When that tricky command word asks you to compare or evaluate different control technologies, you simply cannot just list the pros of one system and the cons of the other. The syllabus requirement is incredibly strict. First, you must identify both similarities and differences. Second, you must logically connect your ideas using explicit comparative connectives, words like whereas, conversely, or in contrast. Third, you absolutely must support every single comparison with solid evidence drawn directly from the scenario, ultimately drawing sharp conclusions about their relative importance. If you skip even one of these 3 actions, your analysis is considered incomplete and you lose points. To truly master this critical analysis, you must also master the time management matrix. Think about it. You cannot spend 40 minutes agonizing over a 10-mark question. You need to systematically evaluate the quality of the evidence, and you need to do it fast. So how do you actually do that? By rapidly addressing these 4 specific elements. Identify the limitations of the control technology presented in the scenario. Acknowledge any underlying assumptions made by the system itself or the human users. Explore alternative interpretations of the data they provided you. And finally, clearly state the effect all these factors have on your overall conclusions. When you systematically check off these 4 boxes, you leave the examiner with absolutely no choice but to award you maximum analytical marks. So let's quickly recap the 3 massive takeaways for mastering Section 3.2. These are the 3 golden rules that guarantee top marks. Rule number 1, command word decoding. You must always know exactly what cognitive domain the examiner's targeting before you write a single word. Rule number 2, apply method. Use that Peel framework application and our 5-step standardized methodology to lock in those critical method marks. Rule number 3, link context. Never ever write a generic answer. Everything you write must tie directly back to the specific control technology scenario they provided. You've got the theoretical foundation, you've got the methodology, and you know exactly what examiner warnings to avoid. Now it's on you. You need to heavily practice past paper questions to cement these skills. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. As you gear up for your IT 9626 exam, I want you to ask yourself this. When you are evaluating an automated system, are you just seeing the basic sensors and wires, or are you finally seeing the underlying logic, the system vulnerabilities, and the broader real-world impact? Because the examiner is waiting to find out. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. AC Exams. Your Cambridge success starts here.